Now we're ready to weld the collar in place. To weld a collar, it does involve preparing two separate pieces of metal and putting them together. So if you're using a propane forge, you'll make a shepherd's hook. And I have a video showing that in action, but I am going to talk through how to weld a collar on the other end of our basket handle. So here is the unwelded part of our basket handle, and the long shaft is out this way that we nicely welded and blended into place. The process here is exactly the same as the one that we started with. The only difference is for a collar weld, this doesn't need to be more than probably about a ½ inch. And we want it round as fast as possible. You want as much material here as you can. Keep it, so want to keep it to a good ½ inch to get that ready to accept the collar. So welding back a ½ inch and taking that to round as fast as possible. Again, you can use this ½ inch bottom swedge, or you could do it on the anvil. The swedge just helps keep everything in place. And you're always going to start with those open ends, welding those to the closed end first. So a collar, we're going to use the same 3/8 inch square bar that we used for the shaft. It's the same material to create the collar. And to do a collar, you need to know what length to cut the material to wrap it around that ½ inch round end that we made on our basket handle. If your collar material is too long, you're going to end up welding the collar to itself, which, you know, we can all probably come up with a couple of uses for a little ring, but it won't be a collar because it won't be welded to your basket handle. If it's too short, you're going to have too big of a gap in the collar material as you close that around the basket handle end, and you'll end up with a thin spot, which is not what we want. We really need the measurement to be just right, or blacksmith right, meaning it's close enough. But that means we need to know how the metal will act, and we need to do some math. So first, let's talk about how the metal is going to act when you take it from a straight bar and you bend it into a circle, which is essentially what we're doing. So this is a 1 inch bar by, it's either ½ inch or 3/8 inch, pretty stout piece of bar. It was cut to 12 inches long and then just made into a circle. And you'll probably notice right away, we have this very collar-like V here that if we tried to blend that shut would end up with a huge divot here, which is not what we want on our collar. We want our collar to be even all the way around. So what happened here? Well, two things happened. One is this material got compressed on the inside. It had a shorter distance to travel. It squished back on itself. And you can see on this side view, this top part is the inside edge. Look at how much thicker that is than the middle. That metal had to go somewhere. It went out here and it went out here, pushing these corners out. The outside edge, which had a longer distance to go, got stretched. That got us a thinner spot here. And it also pushed these corners, pulled these corners back. So you ended up with a shape that we do not want. So we want to get ahead of that. Now, interestingly enough, the only piece of this ring that didn't change in length at all, and I know because I measured it, is this middle line here. This middle line is called the neutral axis. And now that we know this is what the metal's going to do, we can use that neutral axis, this center line, to get our diameter, to get our measurement for how long we need to cut our material. But first, let's address getting ahead of this V shape. And it's actually pretty simple. So here's a bar with no prep, and this white line is our neutral axis. If we want to get ahead of it and get ahead of the metal, like I always think of it as you're outsmarting it because it's so predictable. It's always going to act the same way. If we prep this by taking that inside edge, making it smaller, knowing it's going to push out a little, and we take that outside edge and we make it longer, knowing it's going to retract a little bit, you're going to end up with a circle that has an opening with two flat spots that meet right next to each other. When I did this in February live, or in person, I guess this is live too, but when I did this in person, I had a high-tech flip chart, basically just a big Post-it that I wrote on, and I just took a picture of that to show you the math. So if you're someone who doesn't like a lot of math, I'm going to give you the answer. The answer is we want to cut this bar, this 3/8 inch square material, to 2 5/8 of an inch. But there might come a time when you need to do the math yourself. So I'm going to walk you through that process. The first is we're going to use the neutral axis to get our measurement. In fact, here's our prepped bar. That 2 5/8 is the measurement right down the middle here. That means to get the circumference, which is what we want this length here of this neutral axis, we use this formula. Circumference equals pi times diameter. And the diameter is this little bit of business from this side of the neutral axis to this side of the neutral axis. And conveniently, this 3/8 bar cut in half, we got to do that twice. So 3/16 plus 3/16 gets us right back to a whole bar, 3/8. That's this business right here. And the basket handle, the middle is going to be this 1/2 inch, which is this right here. So our diameter is 7/8 of an inch. To get to our circumference, we plug that 7/8 of an inch diameter into our formula, and we all know that pi is 3.14 something, something, something. But luckily, since we're not machinists, we're blacksmiths, let's just round that to 3. That's close enough. And take the 3 times 7/8, that gets us 21/8, which comes out to what I already told you the answer was, which is 2 5/8. That is the measurement from the middle of this bar to the middle of this bar, which leaves a little bit of a problem because I don't know about you, but I can't cut here and get to here without knowing what this measurement to this measurement is. So to get there, we have to subtract this little bit of business right here from either end. And this graphic shows us how we get there. I got a 3/8 inch tall bar. I have, let's just assume, I have a 45-degree angle on the end of that, and I want this middle to get to that 2 5/8 inch. Well, if I stick a little square, and obviously you would do that in your head, here we're doing it on the graphic, I know that this point right here, where I want to get to, is half of that 3/8 inch bar because a square is the same on all sides. So all I had to subtract is 3/16 from each edge, which is simple enough until you think about the fact that it's probably not a 45-degree angle. In fact, if you look at my happy little drawing, that's not even a 45-degree angle. So we're probably not going to cut it at that, probably more like a 60-degree angle. So let's just subtract 1/8 of an inch from each side of our 2 5/8 from our, to get to our 2 5/8 inch, which means from top mark to the top mark on our prep bar is 2 3/8 inch, because we're going to take 2/8 away from that 5/8. So let's get started with that. The angle can just be put in there with a chisel, and you're not going to have a lot of resistance from this little piece here, so that's just going to angle nicely for you, even with your chisel straight up and down. And then we're going to take this 2 1 2 3/8 and make a mark at the end. At this point, you only want to make a mark. I find it a little fiddly to hold this ruler on top of the metal, so I'm going to give you another option of getting to your 2 3/8 or your 2 5/8 from that neutral axis to neutral axis on the center. And that is, I'm going to go back to our bar here, which has our neutral axis down the middle, and that's what we want to be 2 5/8. I know I got to get an 1/8 inch off of here and an 1/8 inch off of here to get to my 2 3/8. But what if I just took this to this and I moved it all the way to the outside edge? Now I can keep my 2 5/8 inch mark to get to this edge, to the outside edge. And that allows me to take my hook rule, which I just made out of a carpenter's square. I just cut off the 8-inch side to 1 inches. Here's my piece. The taper's up to here, and I can mark this out to the 2 5/8 by just setting this down and making this flush up in that corner, and I'm going to make my mark. You are not cutting the bar at this point. You're only making a mark, because we need to bend that into a C shape before we cut it all the way off. And the reason for that is we want this side hot, we want our collar hot, and we want our basket handle hot. I do not advise putting a teeny tiny little, this is a 2.5, this is 2 5/8 inch worth of 3/8 square metal in a fire. You're going to lose it. So let's use this handle while we can. So put your mark in place, heat this, and always, as always, when you're bending, you're not forging. So you would never hit this metal flush on top of the anvil. You're going to hit it out in the air, drop this hand down until you got a nice little C shape. And you'll notice 2 things. One is the mark is on the inside, the longest side is on the outside. Actually, there's 3 things. This end does not go past this mark, because now you're going to heat this all up. You're going to cut almost all the way through. Leave it hanging by a hair. Heat it up again, heat your basket handle up again, and then you can wiggle this off with some scrolling tongs, place it on the step hot, with your basket handle hot, fit it in the middle, leave a little bit hanging out here, and you're going to hit this outside edge, and with this whole thing up against this step, to wrap that around your bar, leaving a gap here. You want at least a 1/16 of an inch gap. Up to an 1/8 of an inch is fine. You do not want those 2 ends to touch. If those 2 ends touch before you weld this collar, to the basket handle, that's when you just get this lovely little ring. That's not what we want. We want to weld this collar to this handle. So leave a gap so that when we're welding, you're securing that to the handle and then welding this part together. Leaving this inch, about 1/8 of an inch out from the end does two things. It gives you material to blend into place to the top of your handle, as well as it acts like a little bit of a heat sink because we want all this welding temperature. So let's make our collar. So start with that first angle, and by just keeping the chisel straight up and down, you're not going to have a lot of resistance on the end. You're going to end up with at least a 60-degree slant there. Correct for any width. Long side on the bottom. Either measure the top to 2 3/8 or the bottom to top to 2 5/8. Make a mark. And then with the mark down, you're going to bend that. Then and only then do you want to put this all the way almost cut. So you still should see a little space between the bottom of your chisel and your anvil. And now we're ready to heat this up and secure that, wrap that around the basket handle, leaving a little gap. So notice how that step holds it in place. Knock the one side in, knock the other end, and then since it's a circle, move it around, never hitting the same spot twice or you'll start getting flat spots, making sure you have a gap. We're going to watch that again one more time because I want to show you what it looks like if there's too much of a gap. If you end up with something like this, where this is, that's at least 3/16, maybe even 1/4 inch, just knock that collar off and start over. Notice how once this is secured in place, it's still red hot. Brush that, flux it, stick it right back in the fire, and you're ready to weld it. When you weld, you want that open end either at 3 o'clock or 9 o'clock. You're going to hit it on top and then turning the handle so that this gap moves to the 12 o'clock position. Hit, hit, hit. Now this should be welded here. This should start to close. Turn it over. Do the same thing. So if you started at 3 o'clock, turn this over to 9 o'clock, same thing, hit it, rotate, hit, hit, so that you're welding both sides. Brush that, flux that, right back in the fire, do the same thing. Here we did it on the anvil. You can also use 1 1/4 inch swage block, and that will keep this a little rounder. But if you're very careful about not hitting the same spot twice, you can do this successfully on the anvil. The only thing the swage block gets you is the next step when we want to blend this into the top of our handle. The end result we're going for is something like this, where it's a little taller in the middle, a little narrower along the edge. And you can do that on the side of the anvil, but it's easier in the swage block. These bars, these basket handle bars, are gonna wobble about, so you're gonna want to keep them straight as you go and turn this back and forth on the edge here, keeping your hammer, the center of the hammer should never pass the top of the swage block or the anvil if that's what you're doing. So you're really hitting here towards the bottom, and you'll notice this is starting to blend. This is going to take a couple heats, keeping it brushed, fluxed, blend that all the way in, and then once it's blended, and that blending is a weld, You're going to narrow down the sides, or, you know, make this whatever shape you want. I've tried triangles, squares, whatever you want. You could even use a thicker piece of starting material and end up with a square. So, but for this demonstration, we did narrow on the edge and peaked in the middle. So let's watch forge welding here. Notice how the gap is at, well, 9 o'clock to us, 3 o'clock to the smith. Hit it on top and then turn that gap up. Now the gap's on the other side because we welded this side. Hit it on top, turn the gap to the top, and then welding all the way around with a nice white, yellow hot heat. And then you can start on the side of the anvil here to blend the tip. It's much easier in a swedge block, even if your swedge block rocks like that. It's much easier to blend this over this tip. You have more room down here. So that's a collar weld in a coke or a coal forge. If we were going to do our propane option, I'm going to recommend a little longer heat on your basket handle and then turning that into a shepherd's hook. And this is just a video showing you how to do that. It's just a matter of a long taper, and the taper, the size of the shepherd hook is going to dictate how long that taper is, and just putting a little hook on the end and rounding that down, and you could hang that up somewhere. As always, you go from square to octagon to round, and here we are starting the shepherd's hook. Make that little tip, and then starting the shepherd's hook by just taking that around the horn of the anvil. So there you have it. There's your propane option. So we are now ready to twist the basket handle. The twist we want to end up with is fairly modest. If it is going to be a handle for a fire poker or whatever you want it to be a handle for, keep in mind that it's got to fit in your hand, and most handles aren't more than an inch, inch and a quarter inch wide. If you want this basket handle to do something different, you can go through the steps I'm about to show you several times till you get the shape here that you want. And I've tried different shapes, you know, like a bulb here or a bulb here, or nice and even twist. This is a fairly even twist, or you can do a twist with a little bit of a raise in the middle. It's totally up to you. But the process is fairly straightforward. You're going to take a nice even heat on all of the straight bars, and you're going to put it in a post vise, secure it, and then you're going to use a wrench that has had the sides relieved. And in this case, it was modified by welding a bar on the other side, which does allow you to get a more even twist. You're going to cool this, put that in the post vise, and then twist this end. And it's easiest to get a good purchase on a square part of the shaft. Twist that no tighter than this. If these start to jump over each other, that's hard to recover from. You're going to have to straighten it all the way out. And even then, it still might not like what's happening. So don't over twist. Don't let these jump over each other. And at this point, you want to take another nice even heat, because you're going to, using this twisting wrench that you made out of a monkey wrench, push this way and come back about a half a turn to start to open these up. if you've got a nice even heat and everything goes according to plan, these will open up nicely. And these did here. They opened up nicely, all smooth, except for maybe here, they're a little too close together. You can make a tool that looks like a screwdriver, or you can relieve the edges of a screwdriver and just use this to pry some of these pieces in place. If this happened just like this and you want these to be a little wider, if you have a can with a long pour spout on it, you can cool these. This will remain hot and then they'll move easily, but these won't, so that you can start to move your twist into a position that looks good to you. If it doesn't go well, heat it up, twist, retwist, untwist a couple times till you get the shape you want using your screwdriver. But always remember to get a nice even heat if you're going to retwist and untwist this. So that's the end of the basket handle, and the only thing left is the poker end.